Hello everyone. Today let's solve the problem 268 missing number. Right. So what the question states here, we are given an array nums. You can clearly see here we are given an array nums containing n distinct numbers. Right. Containing n distinct numbers. The numbers are distinct here. Right. Distinct numbers in the range 0 to n. From the range, see here 0, 1, 3 we have 301 we have from the range 0 to 3 basically. Right. So we have to return the only number in the range that is missing from the array. So we have 0. So we have 1. So 2 is missing here and we have direct 3. So only the missing number here is 2. So that we need to return in the form of output. See here the output is 2. Same thing for the example 2 as well. Same thing goes for the example 2 as well. So we have from 0 to 1. So here we have 0 and we have 1. Right. So already. Right. So the missing number would be quite obviously the next number here in this case. Right. So it will be 2. So see here in the explanation they have given the same so that we don't get confused. So see here n equals to 2. Since there are two numbers, so all the numbers are in the range 0, 2. 2 is the missing number and the range since it does not appear in nums. So this is fine. So for the third example we have 0, 1, 2, 3, 4, 5, 6, 7. This one 6 here, 7 and 9. Right. So we don't have 8. So we need to return 8 as output. Right. So this is fine. Yep. Let's do one thing. They have given us wonderful examples just for the sake of understanding. Now let's do one thing, man. What shall we do? Let's do one thing. Let's discuss the approach followed by the complexities and then let's write the code. First, let's discuss the approach first as usual. Right. So first thing here, let me tell you, we will be making use of the bit manipulation. Just remember this one. We'll be making use of the bit manipulation. Right. So this is the approach we'll be going with. So here what we will do, we will be going with a missing, that is equivalent to the n. So we'll be going with a missing variable. I'll just consider m here, so which is equivalent to the n. N is nothing but here in this case this one that starts with 3. So we have considered this first example, so it starts with 3 here. Right, it starts with 3 for each index I from 0 to n minus 1. So XOR missing with the I, so we'll be going with the XOR as I've said, bit manipulation, right? XOR missing with I and with nums of I. So what we'll do, XOR will cancel the pairs that appear twice here in this case, right? So let's compute whatever we have discussed now. Let's do one thing. Initially missing we have 3, the number 3, right, at the index 0. So initially the missing will be 3 here, right? So during I equals 0, the first iteration, during I equals 0, what we will do, we will be going with the initial number, nothing but 3 here, XOR nothing but the next number is 0 here, and XOR nums of 0 and XOR nums of 0. So XOR nums of 0 is again 3 itself, the first number, nums of 0, the first one. Current value, this one, initial value XOR this one, what do we call 0, as it is 0th iteration, the first iteration, basically it starts from the index 0, right? 0 XOR 3. So this one will be basically 0. This is 0 itself, right? So this is fine. For the iteration 1, you can just check. So it is 0, the previous value. Initially it was 3, so we have considered 3 here, right? So the previous value we have here is 0, right? So we have to consider 0 XOR this one. First iteration we have 1 here, so this one 0 XOR 1, and this time it will be nums of 1. Previously we had considered this is nothing but the nums of 0. This time we'll be considering nums of 1 basically, right? So this one will be 0 XOR 1 XOR, so nums of 1 is nothing but 0. 0 XOR 1 XOR 0 will lead to value 1 basically. Right. So the final iteration, as we have only 3 numbers here, so this one I equals to 2. So the previous value that we got here is 1 XOR this one. This one basically the iteration 2 we are going with. So this is 2 and this 0 is nothing but the this one, nums of 0, nums of 1. This is nums of 2. The final one, basically the value 1. 1 XOR 2 XOR 1. Right. So this one 1 XOR 2 XOR 1 will give us the output 2 basically. Right. So we have got the output 0, 1, 2 here. So final missing is nothing but the last value that we got here. This one 2. So this is how we are making use of the XOR, basically bit manipulation. Right. So here we have got the value 2. we have got the value, final missing value is 2, so this will be our output. So we have got the output 2, which is equivalent to the output that they have mentioned for the example within the question, right? So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big O of n. So what will be the time complexity here? Big O of n. So why it is big O of n? So we will be making use of one pass over the array, and also it is constant work per element. So overall time complexity would lead to big of n. So what will be the space complexity here? The space complexity would lead to big of 1. So why it is big of 1 here? Because we'll be making use of only a couple of integer variables, right? We'll not be making use of any extra array here. So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively. Right. So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Right. So the first step here would be we will be going with the and we'll be assigning this one to the nums of length. Right. So we'll be making use of the nums of length, length of the nums many times. So I'll just assign this one to the variable n. So this one will be nums dot length. This is fine. So the next step would be we have to go with the start missing with the n. So we will XOR with all the indices accordingly with the approach that we discussed from 0 to n minus 1, right? And all the nums of I as well. So let me initialize missing to n. So this is fine. The next step would be iteration. Quite obviously, we have to iterate through the array, meaning each index I and the value nums of I, right? So this one will be for int I equals 0, I less than n. So this one I plus plus. So within this for loop, what we'll be doing? So we'll be going with the XOR with index and the corresponding value, right? Match pairs cancel out here. So we went with this one. I showed this one step by step, right? So this one missing XOR I XOR finally nums of I. So this one I showed you step by considering the value itself. So now the final step would be after loop, we this one missing variable holds the single number that was not cancelled. Basically, the missing one we will be returning, right? So this one we have to return missing here. So this is fine. So this is it for the code. Right? So let me format the code once and let me hit the run button. So I hope this works for all the test cases. Let's see. I mean sample test cases. Yeah, the sample test cases are getting passed. So let me do one thing. Let me hit the submit button. I hope this works for all the test cases, man. So yeah, all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases. Right? For now, this is it. Thanks for watching, guys.